I want to thank everybody for joining us for today's webinar entitled Sample versus Entity-Centric LIMS, Choosing the Right Approach for End-to-End Efficiency. Today's presentation is brought to you by Asterix and is presented by our friends at Semaphore Solutions, who I'll introduce in just a moment. Before we get into the presentation and our presenters, I'd like to take a moment and introduce you to Asterix. We can go to the next slide, please. And just tell you a little bit about who we are as a company. If this is the first time you're joining us, we obviously want to welcome you. If this is a return visit, we thank you for coming back. So just a little bit about who Asterix is, right? So in the simplest terms, we are a consulting company. We focus exclusively in the life science space. We focus a lot on working with different technology partners in the life science space, R&D space. And we've been doing this for the better part of 28 years. We work a lot on digital transformation. That's a big area of focus for us, helping folks get away from paper and get into these great technology stacks that are available to us now. One of the things that we're always very proud of here at Asterix is that 90% of our staff hold advanced scientific degrees. We are very much a science-based company ourselves, helping other science-based companies. And again, we've been doing this for the better part of 28 years. So that's just a little bit about Asterix. I'm going to introduce our speakers now, and then I'll turn it over to them so we can all enjoy the great presentation. So we go to the next slide. With Semaphore, joining us today is Eban Tomlinson and Julianna Maniscalco. Eban is the Director of Sales and Marketing at Semaphore. He's been doing this for the better part of 20 years, working in the design, implementation, and business-critical informatics systems. Julianna is joining us with a BS in Biology and Chemistry and an MS in Microbiology from Wagner College, and she began her career at the New York Genome Center, where she then went to work on LIMS implementations. So great to have both these speakers with us today. I think Eban's going to kind of get us kicked off. So I'm going to go on mute. I'll enjoy the rest of the presentation with you all. I'll come back on at the end to help out with any Q&A and wrap up. So Eban, you have the floor.
Thank you, Kevin. So welcome, everyone. Today we're exploring a major shift happening in lab informatics, from sample-centric systems to more flexible entity-centric ones. We're first going to define what a sample-centric LIMS typically looks like, and then show how an entity-centric approach differs. Then we're going to dive into why those differences matter, especially for labs dealing with complex workflows and diverse data types that emerge over time. We're going to walk through some real-world implications and highlight how a sample-centric system might become a bottleneck, and then demonstrate how an entity-centric platform easily tackles those complexities and challenges. From there, we'll cover some potential drawbacks just so you know what to look out for, and then contrast those with the major benefits of moving beyond just tracking your samples or tracking in a sample-centric way. Finally, we're going to conclude with some practical steps for transitioning to an entity-centric approach based on learnings from our services side, Semaphore Solutions. And then we're going to wrap up with a Q&A to leave you with clear insights on this emerging paradigm in lab data management. By the end, you're going to have a comprehensive understanding of why entity-centric LIMS solutions are becoming the go-to for digital transformation in modern labs. Let's move to the next slide, please. So, to anchor ourselves, let's take a moment to consider how labs have historically tracked data. Usually that's by focusing on a sample alone if you go back far enough. This might have been perfectly acceptable when your lab processed the same type of sample repeatedly, had a single primary assay, and mostly needed a straightforward record of inputs and outputs like we have on the top here. But but today's reality is far more nuanced. In fields like diagnostics, pharmaceuticals, biologics, and manufacturing, to name only a few, labs need to track not just their sample, but also everything that goes into them, like reagents, instruments, calibration events, staff records, and an ever-growing list of process metrics. You can see that indicated here by a screenshot of Labit's Sample History Explorer, Lineage Explorer. It's quite the evolution, and these two things are not even close to the same. So what's driving this complexity? I mean, partly it's the need for better quality control and compliance. We're monitoring reagent lots down to specific volumes or concentrations to ensure consistent results. We're logging instrument calibration statuses to stay compliant with regulatory guidelines or perhaps internal SOPs. We also see labs juggling entirely new workflows. For instance, combining a genomics-based test with a traditional immunoassay, to name but one. A LIMS built around a single sample record can quickly become cumbersome, even though it might be able to be adapted to that. Even small modifications, and this is where things start to crop up, but small modifications like adding a step to your standard process or integrating a new instrument can feel like a monumental task sometimes. Never mind trying to look back across a series of workflows and potentially workarounds to determine what lots led to a specific result, for example. The outcome of all this is many laboratorians are resorting to a spreadsheet outside of the system or a standalone tool that runs parallel to their LIMS. You might have a piece of software for instrument scheduling, a separate one for reagent inventory, and probably there's an Excel sheet somewhere in your lab. Maybe it's tracking specialized QC data, but who knows, we all have one. Keeping all of those in sync becomes a chore, and inevitably data is gonna start living in separate silos. And it's not that anyone really wants more complexity, it's just that their LIMS typically can't flex to handle those new demands. That's where entity-centric thinking offers a much needed alternative. Instead of focusing purely on the sample, we acknowledge every piece of the lab environment as critical data that should be modeled together like a digital twin, as some of my colleagues are promoting on other webinars that we run. In this way, each aspect of your operations is captured and linked, giving you the freedom to grow and adapt at the pace of modern science without hitting a structural wall every time a new variable enters the equation. So let's start by defining what we mean by sample-centric. So in a sample-centric LIMS, the central pillar of the entire system is the sample record itself. It starts there. Everything else, be it a reagent, a piece of equipment, or a protocol step, is effectively subordinate to the sample. You can see this in the normalized data model on the right. Typically, labs in this model have a linear state-based workflow. You might see states like received, in testing, under review, or completed, and not much detail beyond that. That pipeline can work if your workflows don't deviate much, if, for example, maybe you're running only a single type of assay, or your lab processes are locked in and have been baked over 10 some odd years. However, as soon as you want to run multiple parallel tests on the same sample, or maybe incorporate branching decision points or track new data types, like for example, advanced QC metrics, reagent genealogies or detailed equipment usage, you're going to discover that your LIMS maybe wasn't built to handle this level of complexity. One reason for that is that the relationships among the data points, such as which reagent lots were used with which specific instruments at what time, they're enforced behind the scenes by a combination of software code and the database schema. They aren't naturally expressed in the data itself. That design paradigm forces the vendor software developers and ultimately you to juggle separate tables or modules, or even potentially to rely on a developer to modify the system's logic just to handle a new parameter. Imagine for a second that you want to track reagent volumes at each step of a workflow, or maybe log lab personnel who handle a sample at different times. In a sample-centric LIMS, that's maybe going to require more than just adding a field. It could demand restructuring the workflow or writing custom scripts in order to bolt that additional data on. Over time, those bolt-ons accumulate as technical debt in some cases, or more often in spreadsheets or small access databases existing out to the side. Before you know it, you have dozens of mini systems just to manage tasks that don't fit neatly into the original sample-based design. Not only is that inefficient, but it introduces room for human error, version control nightmares, and difficulty when auditors ask, and they inevitably do, where'd you record the detail of that particular experiment? By contrast, an entity-centric LIMS treats samples as but one type of entity among many. In fact, anything your lab considers important, samples, reagents, instruments, plates, protocols, even people and their certifications or credentials, can be defined as its own entity, each with its own attributes and relationships to other entities. That might sound a bit abstract, but in practice, it mirrors how a lab truly operates. You don't just have sample A floating alone in a vacuum. You have sample A that's combined with reagent B on instrument C, which is run by technician D, and so on. Instead of burying these these connections in the software logic, an entity-centric design stores them explicitly in the data layer. That's a huge shift if you think about it. It means you're going to be able to query your relationships directly. You can ask, what batch of reagent was used in that failed run or succeeded run? Or how many times have we recalibrated this instrument in the last quarter or in the last year, without having to write complex join statements or requiring major schema updates? You basically follow the links in the data in a more natural graph-like structure like you see here on the right. Another advantage is going to be flexibility, but I think that's maybe becoming obvious here. Let's say tomorrow your lab decides to adopt a brand new method involving an extra QC step or a specialized reagent that has a really short shelf life. In a sample-centric LIMS, you might have to redesign that sample state machine or add custom fields, but in an entity-centric LIMS, you define a new entity type or relationship and link it in. That's it. Because the system isn't hard-coded around the concept of a single sample pipeline, or a single sample record, or indeed any other specific data type, it can adapt to novel scenarios really easily. That translates into less overhead on changes, fewer consultant fees, and ultimately a faster time to execution when you want to introduce a new process, assay, or capture a new data element. So why is it that the traditional LIMS sample-centric approach is so problematic for modern labs? There was a recent paper published in Biomedical Databases, admittedly from a computer science perspective, but I think it's very accessible. It provides a perfect illustration of what happens in a relational model, aka sample-centric in this case, or versus a graph-based or an entity-centric model. In their figure 5, as I've copied here, they show how on the relational side, the left, you're going to end up with multiple tables, disease, gene, and pathway, and you're going to be forced to perform numerous join operations to figure out how one concept connects to another. Translating the disease, gene, pathway sort of modeling into sort of a lab operational scenario, you can think of each table as a separate silo for your samples, instruments, reagents, or QC data. And retrieving a complete history of that view is going to mean bridging those multiple silos within a single software system, which might require custom development just to capture new data points and create a clear picture. On the right, however, you're seeing a graph-based view of that same information where relationships are stored explicitly as edges between nodes and in the data. Mapping that back to our LIMS context, each node could be an entity, or actually more specifically is an entity, like a reagent lot or an instrument, and the edges define exactly how they're related, and you can just add to those over time. That model more naturally aligns with the real world workflows and things that you do in laboratories, allowing you to track the transformations and interactions without having to contort your data or yourself into rigid tables that can't easily be remapped without the original software. So if your LIMS is purely sample-centric, the problem really amounts to you're gonna, or you most likely will face hidden costs somewhere. Want to add a new branch in your workflow? That might require custom code. Want to link multiple reagent lots to a single run or use multiple plates? Probably another customization. Over time, those demands add up, and labs are going to end up with data silos, inconsistent naming conventions across spreadsheet add-ons, and probably an uphill battle when regulators or collaborators ask for a clear audit trail of every detail. Ultimately, a system that started out seeming simpler evolves into a Frankenstein of patches and manual processes. It's hardly the digital twin you're going to need for efficiency, compliance, and forward-thinking innovation. All of these challenges mentioned can fester and will probably surface as one of these 3 pains. There are more, but we've chosen 3 for now, that you're going to feel if your LIMS is limiting your move beyond that sample-centric mentality. The first one, lost staff hours. If everyone is repeatedly cross-referencing spreadsheets, retyping data to link samples with reagents or instruments, or maybe manually merging records from different sources, each of those small tasks might only take 5 or 10 minutes, but in a busy lab, those minutes are going to add up significantly over weeks or months or years. If a half a dozen people in your lab are doing this over the course of a month, you can only imagine the cumulative cost in time and productivity. And that's not to mention the human cost of switching their contexts constantly from scientific work to ultimately clerical work. You're going to experience an audit risk or expose yourself to one more specifically. If you pull back and squint at the regulatory regimes enough, they kind of all ultimately will boil down at some level to requiring clear traceability and reproducibility, i.e. show me an audit trail. If your relationships and your data are hidden and scattered within your LIMS, it's going to become really challenging to prove that you followed the correct steps and use the correct materials, especially when that test or study is questioned, things get a little stressful. Labs can spend days reconstructing a single experiment's lineage simply because the LIMS doesn't or maybe can't explicitly store those connections. And then, this is one that we see a lot, delayed onboarding of new assays or slower time to market. Adapting a sample-centric LIMS to a new process often means waiting on vendor updates, custom code, or internal IT projects to deliver new functionality. You can't just snap in a new workflow or entity type. And so your time to market or time to validation really starts to extend out. That delay is costly, both in terms of the opportunity, the business opportunity, but also in staff morale, which is arguably more important for business continuity. Not only does nobody want to see a new idea languish because the software simply can't keep up, but what about, for example, the expectations set by modern consumer software versus what we're using in a lab these days? Julianna is going to show us how an entity-centric LIMS, in this case Labit, tackles these points head on. You're going to see what it looks like to manage multiple plates, track some in-house reagents or in-house manufactured reagents, and handle some more complex relationships, all without the overhead of forcing everything into one narrow sample object. Over to you, Julianna. Let's see what it looks like.
Great, thanks, Eban. So the first real world demo that we have is a question that we get asked pretty regularly. In this scenario, a user has a plate of 96 libraries or pools, and the next step in their process is to plate these samples in triplicate across 3 different output plates that they could then average or find some type of calculation that they're after. Within systems that don't have the ability to map entities, the issue that comes across is loss of shared identity across replicates. A sample-centric system might treat a new aliquot as a separate sample, which would have no inherent link back to the original well source. Data fragmentation is another issue that we see pop up in sample-centric systems, and what is meant by this is instead of having one sample entity with a list of replicate measurements, you get 3 additional samples with disconnected data. This leads to having to do more work offline in Excel to compute the averages. And there's redundant metadata, so this will bloat a system with the workarounds and leads to the possibility of inconsistency, such as editing only one replicate independently. So how to solve this in an entity-centric system? If we go ahead and let's pop out of here, let's sign in very quickly. All right, so if we go ahead and we hop into Labit, the first thing that we are going to take a look at is a history view. And this is a history of showing that example that we just spoke about. You're going to see that our main sample here has 3 replicates associated with it, and those replicates are living on 3 separate plates. If we click into one of them, we'll get that metadata on the right-hand side. So when plates, reagents, controls, libraries, really anything you'd like are first-class entities, this allows us to preserve sample lineage. So if we were to go ahead and hop over to our QC task where we are collecting that metadata, we can see our 3 output containers that have been mapped out. These are all plate entities. And with the aggregation of data, we can see down at the bottom of the screen, we have our samples. And if we expand this out, what we then see is our replicates that are associated back to that parent sample. The system understands that all 3 outputs are expressions of the same underlying sample. And the average or calculated result can be stored on the original sample entity or derived analysis entity, preserving context. This allows for clean, structured data modeling as well as reporting, rather than storing detached values inside of a spreadsheet. So if we go ahead and hop back over to our slideshow here, let's go ahead and go into, let's go ahead and go into our second real world demo. So our second real world demo is going to be manufacturing reagents or lots or buffers, or really any type of consumable inside of your lab. So this network captures exactly what was made, how it was made, how it was later used. And by linking these inputs and processes and outputs, you gain that full traceability across workflows and can pinpoint how specific reagents contributed to particular outcomes. So the problems we run into with the sample-centric system are, in a sample-centric system, there is no first-class representation for reagents. For instance, reagents are often treated as metadata or custom fields on a sample. There's no true identity for that entity representing a reagent as a standalone traceable object. You can't track who made the reagent, from what inputs, under what conditions, or how it was used later. Another issue that we run into is no process-based lineage. So if a reagent is manufactured through a series of steps, such as combining stock solutions, incubation, QC, in a sample-centric LIMS, that can't model that sequence naturally. There's no concept of intermediate entities, so from combining that stock all the way to releasing a QC lot. And the consequence is that you'll lose the ability to reconstruct how a reagent was made or flag batch-specific issues. And then workarounds can usually break that scalability. So to handle these reagents, teams often create stretching out the definition of what a sample is for reagents. So they may model a reagent as a sample, or they may just handle this outside of their systems, like Eban mentioned, and utilize spreadsheets. These workarounds can be a bit complex and pretty brittle. So the solutions don't scale, they break under automation, and they create risk for compliance and reproducibility. So how is this solved in an entity-centric system? If we hop back over into Labit, what we will see here, there we go. Okay, so this is a lot that we've created inside of our lab. This is a lot that we are combining multiple stock reagents together to create a reagent that will be used later on in prep. So with this, we're seeing our history of our mixed stock, and we're also seeing all of the places where this reagent was used. So this reagent that we made in-house was used across several tasks that we can see so far. You can get, again, that additional information by clicking on this expanded view on the right-hand side, but it gives you that history of what happened. So with the clean separation of concepts, reagents aren't forced into sample-shaped boxes. You can model reagents, consumables, and intermediates distinctly and track the relationships between materials without ambiguity. So the benefit of that is no more fake samples or weird naming conventions or spreadsheets to track these reagents. If we go ahead and hop into one of our tasks where we are going to create one of these cell cultures, we could go ahead and add in a new reagent, and we're going to say this is our in-house prepped reagent we're using. We can give it a lot number, say that it was prepared on a specific date, give it an expiration date, and a state in which it's currently mapped out in the system. With there, you can select the reagents that you're putting together to make this final reagent. So we can go ahead and select that in, and now we have a reagent made up of multiple reagents. So the network data across workflows in an entity-centric system builds a graph of relationships. A reagent batch is used in multiple preps, which leads to assay results, and it's all connected and queryable. So now auditing is the same as a sample, since it's all in one system and you're not having to connect the data across several systems. The benefit is it lets you analyze how reagent variability may affect downstream outcomes or vice versa. So if we go ahead and head back into our real world demos here, our third and final real world demo is patient-provider relationship. So in this case, we're going to track and manage every component of a diagnostic test kit from patient all the way to resulting and reporting. and using full traceability, modular entities that reflect the real world workflow in an entity-centric system. This provides you complete visibility from each step of the process, enabling faster turnaround times, higher data integrity, and simplified regulatory compliance. By modeling patients, providers, test kits, samples, and results as an interconnected yet distinct entity, organizations can ensure that auditability, reduce operational risk, and scale workflows confidently as demand grows. So in a sample-centric system, we can see that there is limited representation of real-world complexity. A patient, provider, kit, components, they are, again, forced into a sample-like structure or stored as metadata on fields. Since there's no first-class representation for any of these entities, the impact is that you lose the ability to clearly track how different components relate to each other and what that final outcome is. There's no clean lineage across events, so the relationships are stitched together manually, which often with fragile ID conventions or disconnected systems. So investigations that you need to make within your lab or compliance audits, they become pretty slow and potentially error prone. And this type of system, it's hard to scale or automate. So as your lab is growing, it's hard to keep up with what these workarounds actually are. So in an entity-centric system, before we jump into how it could be modeled in LabIt, what we take a look at here is this is a pretty simple linkage of what could potentially happen. You have your healthcare organization, you have a healthcare provider that is linked to that organization, and a healthcare provider puts in a test request for a specific patient, and that test request then becomes a kit. In an entity-centric system, these would all be individual entity types. As you could imagine, this could get pretty complex pretty quickly, where if you go into the doctors and you're sick and they want to go ahead and set out a panel of tests, you can have a test request for the flu, COVID, strep, and those are all entity types that could be linked back. These examples could continue to grow, and as you can see, they get very interconnected. So you could have different organizations, different healthcare providers reporting back to those organizations, and having your entities mapped out in such a way, it will allow you to start to build out this knowledge graph. Same thing for introducing in additional patients. With an entity-centric system, the pairings really are endless. So if we were to go ahead and hop back over into LabIt, if we took a look at let's refresh quickly. If we hopped over into our testing workflow, we utilize BPMN. So this BPMN is just a great representation of what you're going to see inside of an entity-centric system. We're starting with that test request. That test request is becoming a kit. That kit is becoming a test, and so on and so forth until you get those reported results. So if we were to hop into one of our test requests that have been completed, this is a very simple view here, but what this is showing us is that they're all just links that are associated with each other. We have our test requests, and in our test request, we can see that we have related them back to our HCP and our associated patient. If you wanted that additional metadata on what your healthcare provider is, you have that linked together, and then reporting back, you could always start at any point inside of this network of linked entities. So these allow for seamless integrations with entity-based APIs to make connections with your EHRs, your LIMS instruments, very seamless, and it reduces that custom middleware burden, and you're able to handle error handling better as well as debugging, because errors are localized now to these specific entities or relationships. For instance, kit X is missing reagent Y, rather than buried in the general sample processing flows. So it really does make that troubleshooting clearer and faster. The key takeaway points here is that you don't have to conform your business to a system versus being able to take that design and model it with your business as well as grow with your business. So I'm going to go ahead and pass it back over to Eban.
Thanks, Juliana. So, of course, no approach is perfect, and this entity-centric model brings its own challenges. The one that I see the most, and kind of first off, the buying experience for an entity-centric system tends to be a bit more complex because it requires a bit better process documentation from your lab. That's because the system is so flexible that you've got to invest a bit of time defining what entities and workflows matter to you, what data you want to track for each, and in particular, how they're going to interact over time. Labs that are expecting, as it has been in the past, but are expecting a vendor to guide how they work, or maybe they're used to like a turnkey sample in results out type solution, might initially find that a bit daunting. But maybe think of it like building a house with an architect rather than buying one that was pre-built or a spec house. It might be more work up front to get going with a plan, but in the end, you're going to end up with a sustainable space that's tailored to your exact needs, that's built better, and more importantly, built faster because you had a clear plan. Secondly, there's less out-of-the-box functionality in some cases. Certainly, we're always working to deliver as much as we can out of the box, but an entity-centric LIMS ultimately doesn't dictate that your sample must move from waiting to testing to completed, for example. Instead, it's up to you to define those processes that are relevant to your lab and how they interact with what you're actually trying to do. A lot of labs really love that freedom because they can replicate their real world actual workflows and match the data that they're capturing up with those real world workflows without any kind of forced compromises or adaptation required for humans to work around a software limitation. Others, though, might miss having everything predefined and that really rapid startup and that needing that, like they want that guidance to set up their systems properly. They're looking for like a best practice, for example. And third, and this one's been the most interesting to watch as Labit evolves and comes into the market, is the scope creep is a real risk. Once the humans in the lab see that anything is really possible, we don't ever really give an answer like, hey, no, that's not possible. It becomes tempting to track everything or to customize everything or to configure everything. I mean, like every beaker, every pipette, everything in your supply closet. But not all of that data is equally crucial. Pretty clearly, those examples are kind of trivial, but it becomes really easy to go overboard in your first implementation phase, which in turn is going to bog down your timeline and sort of challenge your project. We've found that a best practice is to start with the highest impact workflows. Maybe it's a main QC process or a high volume test, and then expand after your laboratory's gotten used to the idea that they can have whatever they want. That controlled approach prevents the project from ballooning and ensures that you're realizing value out of your LIMS early and, frankly, often as you expand. On the plus side of all of that, just to sort of reframe it, that upfront work of defining your entities, the relationships between them and the processes or workflows, it ultimately can be a net positive. By clarifying those needs early and then articulating them to your LIMS provider or possibly your new LIMS vendor, you're ensuring that you're selecting and configuring exactly the right system for your lab's reality rather than purchasing something expedient and ending up with a one-size-fits-all design and then endlessly layering on workarounds, for example. In short, fewer surprises are going to pop up later and you're going to enjoy a better alignment with your real-world workflows. Next slide, please. Oop. So, in addition to selection confidence, an entity-centric LIMS offers what we think of as transformative benefits. Let's just break down 3 of them, for example. The first is the ability to consolidate your systems. So maybe you're juggling multiple software platforms. We've seen stats from around the laboratory industry that scientists are dealing with like 7 to 9 different systems at any given time. Maybe you've got one for tracking samples, another one for equipment calibration, a separate reagent management system, possibly a QMS somewhere. An entity-centric approach can actually unify all of those and beyond. That's because every aspect of your lab is just another entity to the system. You fold them into one integrated environment just by drawing out your workflow and then defining a new entity or two to go through those things. That in turn can reduce your license fees overall, cut your IT overhead, and most importantly, it's going to save staff from having to duplicate effort in multiple systems or software projects to integrate those multiple systems. The second benefit is in streamlining operations. Imagine you're investigating a test anomaly. In a sample-centric LIMS, you'd look up the sample record, and then if you were using a bunch of workarounds, you'd have to fish through separate modules or potentially even paper logs to see what reagent lot was used and which instrument was involved, for example. In an entity-centric LIMS, as Julianna showed as she was clicking through our sample history views, those relationships are stored explicitly, so you can just click through the path from sample to reagent to instrument and even see on that instrument record when it was last calibrated, and it's no more than 1 or 2 steps. It eliminates guesswork and manual cross-checking that often plagues labs, and in turn, it also demonstrates like concordance between what you plan to do and what you did, which regulators will always love. And then finally, and probably the biggest one, is the cost savings, right? By removing that redundant enterprise software and minimizing the patchwork of custom scripts, you're gonna cut both direct spending and the hidden people costs. That's the staff hours spent wrestling with a system that doesn't really match their reality. Over time, as you add new tests or scale up your operations, the flexible data model is going to pay off. It's going to continue to pay off, letting you adapt quickly. It's not just about saving money, it's about redirecting resources to what truly matters, doing science, innovating, and meeting your lab's strategic goals. So let's shift gears on the next slide from why to how. You might be thinking, I see the upside of an entity-centric system, but how do I actually get to one? How do I implement it? This is a straightforward approach, admittedly a bit simplified, but a straightforward approach that I borrowed from our services arm, Semaphore Solutions. So this is the actual process we would take to implement Labit, for example. We start with the basics. We identify our core entities. Those are samples, reagents, instruments in the most common cases. And then we decide if we also want to represent other things within the process, or maybe even personnel and their credentials as entities. We advise being selective at first. Focus only on what truly matters for traceability and workflow efficiency. Step 2 is to define your relationships and workflows. Map out how those entities interact. Whiteboards are going to be your best friend here. Does a reagent get consumed in a particular step in a particular workflow? Do your samples get pulled together, and when do they come back apart? Even if it's just in data, virtually, so to speak. Are there branching decision points depending on QC results? By capturing those relationships up front and the data that drives them, or excuse me, the parameters that drive them up front, you're going to set a really solid foundation for your data model and workflow interactions, and ultimately the implementation of automated routing, for example, within the LIMS. Step 3 is to configure your data model. That sounds probably a bit daunting, but in a modern LIMS platform, you should be able to do this easily, especially if it's built on graph or semantic technology like Labit is. You can use a graphical interface or maybe some straightforward configuration to add a new entity type to others and then link them all together. And this is where your vendor or an internal team might help you translate your blueprint into a working configuration. There is some nuance here, but don't shy away from it. It's not challenging. And then step 4, pilot a high value workflow. Start small, pick one of your core processes. Maybe it's a small QC protocol, or maybe you can do a frequently repeated assay. Implement it in the system, gather some feedback from your colleagues, adjust the entity and workflow definitions as is needed. You're not really limited in what you can adjust there, and then make sure that people are comfortable with it before you start scaling up. And then finally, and this is a repeated step, you've got to iterate and expand. Once you see those tangible benefits, maybe it's time saved or clearer traceability or easier reporting or emergent data being captured, you can start to bring on additional workflows or data types beyond the scope of what you're just doing kind of day to day and here and now. This type of phased rollout really helps keep the project manageable, and it's also going to allow your team to learn the system deeply rather than tackling every process at once and burying it under a ton of automation, which kind of hides what the LIMS is actually doing in some cases. So following these steps is going to ensure that you don't get overwhelmed trying to boil the ocean on day one. You're going to capture immediate wins while laying the groundwork for a more robust and ultimately future-proof system. And that ultimately is the beauty of an entity-centric design. you can adapt it to your lab's evolving needs without uprooting your entire software infrastructure every time you want to change. That's in stark contrast to you having to adapt to how a LIMS or another chunk of software does or thinks. And just to make it all the more attractive, even if you decide to stop after step 2, you've just workshopped out your entities and workflows, you're still further ahead because that information is precisely what we as a vendor would need in order to price out a project of implementation for you, or even for you to start doing like, this is what we're currently tracking, and here is where we're going, as in this is the change we want to make for additional efficiency. So in conclusion, we started out today's webinar by asking, like, what does a LIMS really need to be in a modern laboratory context? We think the simple truth is that focusing on that sample is no longer enough. You can't build and branch out from there. You've got to think about it more comprehensively if you want to stay competitive, if you want to maintain rigorous compliance, and more importantly, if you want to foster that real innovation amongst your staff. An entity-centric approach not only evolves with your science, but it's also going to integrate every single corner of your lab, simultaneously eliminating those fragmented tools and data silos, while in turn creating that digital twin that you hear across the industry these days. Whether you're a small research lab looking to grow and create real value in your informatics stack, or if you're a large enterprise that's wrestling dozens of software systems from multiple acquisitions and multiple lab sites together, entity-centric thinking provides a path forward that is manageable and controlled. Here at Labit, our mission is to help you build that future-ready foundation. We are committed to making sure that your data model stays as dynamic as your science. You're never forced to choose between agility and compliance. You can have both. If you're considering a LIMS upgrade or you just want to break free from the constraints of your current architecture, we'd love to show you how Labit can help you achieve that entity-centric transformation. So with that, I want to thank you all for your time and attention. We've covered a lot of ground, from why sample-centric can be limiting to how entity-centric solves those limitations. We did a few real-world demos, and we've given you a clear path to get started. We're going to open the floor now for questions. I think Kevin's going to take over for me. And ultimately, Julianna and I are excited to hear your thoughts, experiences, and any challenges you're facing in your own lab environments, and we'll see if we can help somehow.
Yeah, thanks, Evan. Wonderful presentation to both of you, actually. Really good stuff, very compelling. A couple things here real quick. One, we stopped the recording at this point.